One of the most useful skills you will learn in math and science is a technique called dimensional analysis that is used to convert units of measurement. The technique has a variety of names. It is also known as unit analysis, factor label method, factor unit analysis, and picket fence in reference to a setup used by some teachers that resembles a picket fence. But what's in a name when the method will give you not only a way to brainlessly convert the most complex of units, but also a way to effortlessly solve those greatly feared stoichiometry problems in chemistry. At one time or another, by this stage in your education, you've all had to convert units. Maybe it was to change hours to minutes, or maybe kilograms to pounds or ounces. You knew you needed some basic definitions and equivalencies, but the big question was what to do with that information. Like everyone else, you always wondered whether you need to multiply or divide. With the dimensional analysis method, you will never need to ask that question again. The technique is versatile, and for you to appreciate all that it can do, I have split this lesson into 3 parts. In part 1, I will define the concept. I will then go on to explain its setup. Depending on the definitions and equivalencies we have on hand, this may be done in one step or in multiple steps. I will then explain the idea of conversion factors, what they are and how they are derived. In part 2, I will talk about conversion of fundamental units. These are units that have only one dimension. We will look at the imperial system with units like pounds, ounces, feet, and miles, as well as the metric system with units like grams and meters. And in part 3, we'll look at the conversion of derived units. These are made up of a combination of units, like the squared units that are used for area, or the cubed units that are used for volume, and other combinations like the units of distance over time used for velocity, or mass over volume used for density. Let's begin with part 1. The objective in this technique is to convert units, and here's a good way of looking at it. If imagery helps you, you can think of it as a transformation, entering with one identity and exiting with another. Without realizing it, we are constantly doing such transformations in our heads. When we hear 0.25 hour, most of us understand it as a quarter of an hour or 15 minutes. Essentially, the information has entered as hour and exited as minute. Obviously, this conversion was an easy one. There was no need for a calculator and no need for the formal setup of dimensional analysis. But we will use this same example to see how dimensional analysis would give us the same result. Let's discuss the setup. For reasons that will soon become obvious, one setup in dimensional analysis has also been called the picket fence. Through a series of well-chosen fractions called conversion factors, we have here converted the unit A to the unit F. The choice of conversion factors ensures that similar units in numerators and denominators cancel so that at the end of the process of serial conversions, we are left with the desired final unit. Here's how the conversion factors are chosen. In this example, we are converting A to F. The unit to convert a is written as a numerator. The first conversion factor must have the unit a as a denominator in order to cancel the numerator a in the previous fraction. The second conversion factor must have the unit b as a denominator in order to cancel the numerator b in the previous fraction. The third conversion factor must have the unit c as a denominator in order to cancel the numerator c in the previous fraction, and so on until the desired unit is reached. But not everyone uses the picket fence setup. I prefer the more conventional style showing multiplication signs and fractions. The end result is the same. A has been converted to F, only the look is different. Though this generic example shows a multi-step conversion, the overall algorithmic pattern is the same for all conversion types. In this specific example, we want to convert 157 kilograms to its equivalence in pounds. Pulling out our equivalencies, we see that the conversion will be a direct one, indicating a single-step conversion. We set up the procedure using the appropriate conversion factor. We cross out units, and, like magic, the initial unit has transformed to another. We have thus algorithmically and effortlessly converted 157 kilograms to its equivalence of 345 pounds, having kept 3 significant figures to match the number of significant figures in the initial measurement. Note that the number of significant figures in the final answer depends only on the number of significant figures in the initial measurement, and not on the number of significant figures in the equivalencies and definitions that we use. In this second example, judging from the information on hand, we cannot do a direct conversion. We will need more than one step, a multi-step conversion, to change kilograms to ounces. But the pattern is the same, and through appropriate conversion factors, we can convert 157 kilograms to its equivalence of 5,530 ounces, keeping, once again, 3 significant figures. Let's take a deeper look at conversion factors, what they are, and how to derive them. You have probably gathered by now that conversion factors are derived from equivalencies and definitions. Their concept follows a purely mathematical argument based on fundamental theorems. A definition or an equivalency is expressed as A is equal to B. We argue that if A is equal to B, then by dividing both sides by B, we obtain A over B is equal to B over B. This concludes that A over B is equal to 1 because B over B is equal to 1. Let's develop the argument further. If A is equal to B, then B is equal to A. This time, we will divide both sides by A, giving us B over A is equal to A over A. We obtain B over A is equal to 1. From the equivalency A is equal to B, we now have 2 fractions, A over B and B over A, both of which equal to 1. These fractions are called conversion factors, and the important thing to remember is that they are equal to 1. We have thus seen that from one equivalency, we can obtain 2 conversion factors. The argument continues that if a conversion factor is equal to 1, then we can take a measurement with a certain unit and multiply it by any number of conversion factors without changing its magnitude. Through this process of serial transformations, we have converted kilograms to ounces, which is our final destination. To obtain the value, we take the product of the numbers in the numerators and divide it by the product of the numbers in the denominators. 157 kilograms has been converted to 5,530 ounces. Now we'll look at the previous example of a one-step conversion to see how we obtained the conversion factor. A highly precise equivalency gives 1 kilogram as equal to 2.20462262185 pounds. For our purposes, this is far greater precision than we need, and so we will satisfy ourselves with the two significant figure equivalency of 1 kilogram is equal to 2.2 pounds. To derive our two conversion factors, we will follow the same steps as in the previous generic example. Dividing both sides by 2.2 pounds, we have 1 kilogram divided by 2.2 pounds is equal to 1. And if 1 kilogram equals 2.2 pounds, then 2.2 pounds is equal to 1 kilogram. And so, for the second conversion factor, we divide both sides by 1 kilogram to get 2.2 pounds over 1 kilogram is equal to 1. Our two conversion factors are 1 kilogram over 2.2 pounds and 2.2 pounds over 1 kilogram. Now you try it. For the next three examples, you can engage in your own learning by answering some questions when prompted. At these visual prompts, pause the video, think about the answer, then click to resume the video and to check your answer. Example 1. What are the two conversion factors for 1 pound is equal to 16 ounces? Let's see how we get our answer. Given 1 pound is equal to 16 ounces, divide both sides by 16 ounces to get the first conversion factor. Given 16 ounces is equal to 1 pound, divide both sides by 1 pound to get the second conversion factor. And our two conversion factors are 1 pound over 16 ounces and 16 ounces over 1 pound. Example 2. What two conversion factors can be used for converting between inches and centimeters? Answer. From a table of definitions and equivalencies, find the required equivalency. To obtain the first conversion factor, divide the left side by the right side and you have 1 inch over 2.54 centimeters. And to obtain the second conversion factor, divide the right side by the left side and you have 2.54 centimeters over 1 inch. Example 3. What two conversion factors can be used for converting between feet and inches? Answer. On your table, find the required equivalency. The two conversion factors are 1 foot over 12 inches and 12 inches over 1 foot. In part 2 of this lesson, we will look at conversion of fundamental units and we'll examine both the imperial and the metric systems of units. To do that, you need to be familiar with both systems of units. Many of you may not be familiar with the imperial system, and though most countries in the world do not use it, it does help to know some of the more common imperial units, their symbols, and their equivalencies. Of course, you can always look them up, but it never hurts to memorize a few essentials. Three very handy definitions and equivalencies you might want to store into your memory bank are 1 cc is equal to 1 centimeter cubed is equal to 1 milliliter. 1 inch is equal to 2.54 centimeters, and 1 kilogram is equal to 2.2 pounds. The idea is always the same. We might want to change metric to imperial, or the reverse, and we might want to change metric to metric. As an example, let's look at this problem where you need to convert 7,920 feet to miles. Start off by setting up the process. Write the first measurement, a multiplication sign, and the divider line for the first conversion factor. Pull out your table of definitions and equivalencies. You find that 1 mile is equal to 5,280 feet. Remember that each equivalency has two conversion factors. You will choose the one with feet in the denominator to cancel out the unit feet in your starting point. You are at your destination. Do the math, and you get 1.50, keeping the three significant figures from your starting point, and write down your final unit. 7,920 feet is equal to 1.50 miles. Now let's say you want to convert 0.125 gallons to milliliters. Set up the process and pull out your conversions table. Because this particular one does not give a direct conversion, you need to plan a route that will take you to your final destination. The plan will involve converting gallons to quarts, quarts to pints, pints to cups, and cups to milliliters. Clearly, it will be a multi-step conversion, but the pattern is the same, only the process is longer. The first step is to convert gallons to quarts. Choose the appropriate conversion factor to cancel out gallons. If you stop here, your answer will be in quarts, so you will need to proceed to convert quarts into pints. Pints into cups, and cups into milliliters. You are at your destination. Calculating the numbers gives 473, and the unit is milliliters. In a straightforward algorithmic method, you have converted 0.125 gallons to its equivalence of 473 milliliters. Note that your answer will have three significant figures. Now you try the next two examples. On the prompts, pause the video, think about the answer, then resume the video to check your answer. Example 1. Convert 157 kilograms to pounds. Answer. Set up the process. Find your equivalency and choose the appropriate conversion factor. Cancel out units, and you're done. Do the math, keeping 3 significant figures, and write your final unit. 157 kilograms is equal to 346 pounds. Example 2. Convert 5,530 ounces to kilograms. Answer. Set up the process. Multiply by the first conversion factor to cancel ounce. Multiply by the second conversion factor to get to kilogram. Remember that this particular conversion factor is a very handy one to memorize because it is a linking equivalency for the mass unit between the metric and imperial systems. Once you're at your destination, carry over the unit and do the math by dividing the product of the numerators by the product of the denominators. 5,530 ounces is equal to 157 kilograms, and that is 3 significant figures in both the initial and final values. In the last examples, we've looked at conversions between imperial and metric units. In the next section, we will look at the conversion within the metric system. And an essential part to doing such conversions is to start with the metric prefixes and their definitions. The list looks absolutely daunting, but it's manageable. Some prefixes you are already familiar with. From your work with computers, you may have come across tera, giga, and mega. And in biology, you may have encountered micro, nano, and pico. But don't worry, it is not necessary to know all of them. And I bet the ones you need to know, you already know. And if you don't, here is a handy mnemonic to help you remember.
Huh? Mnemonic? Oh, you mean a memory aid.
Yes, a memory aid. It goes, King Henry died, you didn't care much. The K stands for kilo, H for hecto, D for deca. The U stands for any metric base unit like gram, liter, meter, or others. D stands for deci, C stands for centi, and M stands for milli. Let's do an example where we need to convert 48 kilograms to grams. We start off at the starting point and we write 48 kilograms, a multiplication sign, and the divider line for the conversion factor. At this point, we'll still use our table of metric prefixes, but hopefully soon you will no longer need it. The plan is straightforward. It is to go from kilo to the base unit, in this case, grams. By definition, the prefix kilo, symbol lowercase k, means 1,000. So, 1 kilogram equals 1,000 grams. This equivalency gives us the 2 conversion factors, and we choose the one with kilograms in the denominator. Canceling units gives grams in the numerator, and we are at our destination. Doing the math gives 48 kilograms is equal to 48,000 grams. We'll now convert 48 kilograms to milligrams. Note again that in dimensional analysis, conversion factors are derived from established definitions and equivalencies. And established definitions in the metric system are all based on the base unit. So, in converting kilogram to milligram, we must progress from kilogram to the base unit gram and then to milligram. In the previous slide, we saw that to convert kilogram to gram, we need to multiply by the conversion factor 1000 grams over 1 kilogram in order to cancel kilogram. This brings us to gram, which will now be converted to milligram. From our knowledge of prefixes, we know that milli means 1,000th. So, 1 milligram is equal to 1,000th of a gram, which can be written in 3 different ways. For our purposes, we will use the first style, which is the least messy when we are dealing with the fractions used in conversion factors. From this equivalency, we obtain our 2 conversion factors and choose the one with gram in the denominator. The unit gram gets cancelled, leaving us with our destination unit of milligram. Doing the math and carrying over the unit gives us 48 kilograms is equal to 48 million milligrams. Next, we'll convert 8,500 centigrams to pounds. The plan will be to use metric prefixes to change centigrams to kilograms, and then to use the metric to imperial linking equivalency of 1 kilogram is equal to 2.2 pounds to change kilograms to pounds. Now let's do it. Remember that to go from centigram to kilogram, we must convert to the base unit first. Centigram is changed to gram, then to kilogram, and finally to pound. Carry over the remaining uncancelled unit, calculate the product of the numerators, and divide by the product of the denominators. The 2 significant figures in the initial measurement determines that the answer will have 2 significant figures. 8,500 centigrams is equivalent to 0.19 pounds. Now you try the next example. Example: convert 45 meters to yards. Answer: is this how you did it? If not, here's how to think through the process. You know that meters is metric and yards is imperial, and you know that the linking equivalency between metric and imperial linear units is 2.54 centimeters is equal to 1 inch. So here's the plan. It is to use metric prefixes to go from the base unit meter to centimeter. Then to use the linking equivalency to go from centimeter to inch. This gets us to the imperial system, and with more help from our table, we can go from inch to foot, and finally to yard. Now start the dimensional analysis process with the proper conversion factors until you get to the destination unit. Carry over the destination unit, which has remained uncancelled. Do the math by dividing the product of the numerators by the product of the denominators, and you get 49.2. Remember to change this value to 49 in order to maintain the two significant figures of the initial measurement. 45 meters is equivalent to 49 yards. In part 3, the final part of this lesson, we will look at conversion of derived units. These are complex units composed of two or sometimes several different units. We will focus on the conversion of the simpler combinations, such as units for area and volume, and later we will look at conversions of units for variables like velocity and density. We'll start with units for area, which are in units squared, and then we'll look at units for volume, which are in units cubed. To understand conversions of squared and cubed units, we need to look at some basic math. Let's calculate the area of this square. It is equal to 1 squared inch squared, or 1 inch squared. Let's expand on this. If 1 inch is equal to 2.54 centimeters, we can say that an area of 1 inch by 1 inch can be rewritten as 2.54 centimeters by 2.54 centimeters. The area of this same square with the same dimensions but in different units gives us 2.54 squared centimeters squared. Note that this can also be written as 2.54 centimeters all squared. We can then go ahead and do the calculation. However, it is best to express the area as 2.54 squared centimeters squared. This style avoids unnecessary calculations and reminds us to square the 2.54. The equivalency is written as 1 inch squared is equal to 2.54 squared centimeters squared. The conversion of units cubed works in the same manner. Follow the proof to see how 1 inch cubed is equivalent to 2.54 cubed centimeter cubed. We can now summarize in a table the information we have just learned. Based on the unidimensional conversion factor, 1 inch is equal to 2.54 centimeters, we can obtain equivalencies for two-dimensional and three-dimensional units. And from each of these equivalencies, we can obtain two conversion factors. In this example, we'll apply what we've just learned. To convert 4.00 inches squared to its equivalence in centimeters squared, we will use 2.54 squared centimeters squared over 1 inch squared as our conversion factor. Inch squared cancels out, and our three significant figure answer is 25.8 centimeters squared. To see how this works, we will break down 4.00 inches squared into its components of 4.00 times 1 inch times 1 inch, which can be rewritten as 4.00 times 2.54 centimeters times 2.54 centimeters. We will then rearrange this information and group numbers with numbers and units with units. Multiplying the numbers and multiplying the units gives the same answer of 25.8 centimeters squared that we got with dimensional analysis. Converting units cubed follows the same process. The only difference is that now the conversion factor has cubed units. 27 centimeters cubed is equal to 1.6 inches cubed, keeping two significant figures. This next example is challenging. You try it. Example. Convert 65 hectoliters to meters cubed. Answer. "65 hectoliters is equal to 6.5 meters cubed." Finally, we'll go over units for velocity and units for density. The conversion of units for both of these variables is handled in the same way and follows the same principles used in more straightforward dimensional analysis. In the cases of velocity and density, the derived unit is composed of two parts, with one unit in the numerator and the other in the denominator. The goal, as in any conversion, is to change the initial unit to the final unit through serial transformations. With derived units, however, this is done with one unit at a time. And it makes absolutely no difference whether you start with the numerator or the denominator. Once you know how to handle velocity and density, you will be able to convert all other derived units, such as those for variables like luminance, gravitational force, acceleration, concentration, or any other unit thrown your way. Here's a worked example of unit conversion for velocity. To convert 1.8 meters per minute to centimeters per second, we must convert the distance unit meter to centimeter and the time unit minute to second. The process starts in the usual way. With one conversion factor, meter is converted to centimeter. Indeed, if we stop here, the answer will be in centimeters per minute. So, it is important to remember to convert the unit in the denominator as well. Now, another conversion factor changes minute to second. With centimeter in the numerator and second in the denominator, we are at our destination unit of centimeters per second. We carry over the units and do the calculation. 1.8 meters per minute is equivalent to 3.0 centimeters per second. This one is a very challenging density conversion. You need to change gram to ounce and liter to foot cubed. And the process begins. By this point, metric prefixes should have become a part of your knowledge. But it's still all right to get some help from a table of imperial equivalencies. Once you're at the destination unit in the numerator, you can start working on the denominator. Using information you have, you now convert liter to foot cubed. The destination units are carried over and the calculation is done. And that's an interesting and surprising answer. 2.5 grams per liter is equivalent to 2.5 ounces per foot cubed. Now you try these next 3 examples following the prompts. Example 1. Convert 2.50 meters per minute to centimeters per second. Answer. .50 meters per minute is equivalent to 4.17 centimeters per second. Example 2. Convert 4.80 inches per second to meters per hour. Answer. .80 inches per second is equivalent to 43.9 meters per hour. Example 3. The density of pure silver is 10.49 grams per centimeter cubed. Express its density in ounces per inch cubed. Answer. .49 grams per centimeter cubed is equivalent to 6.050 ounces per inch cubed. Thank you for watching. I hope this video was helpful.